Standard 10th Mathematics Part 2 Chapter Trigonometry. In solving practice set problems in video number 10. With application oriented problems in trigonometry in the practice set, the problem on the board says, if cot theta is equal to 40 upon 9, find the value of cosec theta and sin theta. The diagram is drawn to you, children. It's a right angle triangle. First, to begin with, let's use the method by applying trigonometric identity. Now, cot theta is given to you. So, the trigonometric identity used can be 1 plus cot square theta is equal to cosec square theta. Let's substitute the value of cot theta, that is 40 upon 9. So 1 plus 40 upon 9 the whole square, which is equal to cosec square theta. To move on with our mathematical calculations, 1 plus 1600, 40 square is 1600 upon 9 square is 81, which is equal to cosec square theta. Again, LCM on the left hand side. As we know, there is no denominator, that means it is 1. The LCM between 1 and 81 will be 81. To equalize the first denominator to the LCM, multiply by 81. So numerator also by 81. 81 means 81 plus 1600 as it is, which is equal to cosec square theta. 81 plus 1600 is 1681 upon the denominator 81, which is equal to cosec square theta. To move on with our calculations, children, we want only the value of cosec theta. So taking the square root on both the sides, I will rewrite it. Cosec square theta is 1681 upon 81. Taking the square root on both the sides, square root of cosec square theta will be equal to square root of 1681 upon 81. On the left hand side, children, square root of cosec square theta is only cosec theta, which is equal to, now square root of 1681 is the square of which number gives us this value? It is 41 square. So square root of 1681 will be 41 upon square root of 81, that is 9. So finally we have calculated the value of cosec theta, which is equal to 41 upon 9. How do we get the value of sin theta, children? We know what is cosec theta. Cosec theta is the inverse of sin. So if cosec theta is 41 upon 9, sin theta, what is sin theta? It is 1 upon cosec theta. That means 1 upon, what is cosec theta? 41 upon 9, which gives us 1 as it is. Division change it to multiplication. Reciprocal of the number in the denominator. That will be 9 upon 41. Let's multiply. 9 ones are 9 upon 41. So the value of sin theta therefore is equal to 9 upon 41. So by using Pythagoras theorem, we were able to find out the value of cosec theta, that is equal to 41 upon 9, and the value of sin theta, that is 9 upon 41. What did we use over here? We used the trigonometric identities. Now, what was the alternative method, children? By using Pythagoras theorem. Let's calculate by using Pythagoras theorem to find out the values of the unknown. For that, the right angle triangle is already drawn. The ratio of cot theta is given, that is 40 upon 9. Now, what is the length of AB, BC and AC? Let's first calculate with the given trigonometrical multiplicative inverse, that is 40 upon 9. What is cot of theta? It is adjacent side upon opposite side. Adjacent side upon opposite side. That means length BC is the adjacent side and length AB is the opposite side. And cot theta is adjacent side upon opposite side. But this is a ratio. To convert it into the measurement of the length, let's assign a variable. So length will be 40x upon the length of AB will be 9x. So this is 40x and length AB is 9x. So cos theta is equal to adjacent side upon opposite side, that is 40x upon 9x. X and x gets cancelled and we are left with the ratio. Now let's use Pythagoras to calculate AC. That is the alternative method to find out cosec theta and sin theta. How do we apply Pythagoras theorem? AB square plus BC square is equal to AC square. What are we applying over here? Pythagoras theorem. So over here AB is 9x, so 9x the whole square, plus BX is 40x, that is 40x the whole square, which is equal to AC square. What did we do over here, children? We substituted the values of AB and BC. 9x the whole square is 81x square plus 40x into 40x is 1600 x square, which is equal to AC square. What is common? X square is common, into bracket 81 plus 1600, which is equal to AC square. Let's move on with our mathematical calculations. X square into, inside the bracket 81 plus 1600 gives us 1681, which is equal to, on the right hand side, AC square. X square into 1681 is 1681 x square, which is equal to AC square. In other words, AC square is equal to 1681 x square. Taking the square root on both the sides, as we only want the value of AC. So, square root of AC square is equal to square root of 1681 x square. Let's move on further with the calculations. So what do we get? On the left hand side, square root of AC square is just AC. And as we are dealing with the lengths of the sides, let's only use the positive value and discard the negative one. So square root of 1681 is 41 and square root of x square is x. So length AC is equal to 41x. Now children, as we know all the three lengths, we are able to find out all the remaining values, even though they have only asked cosec theta and sin theta. Let's stick to it first. So what is cosec theta? Cosec of theta is hypotenuse upon opposite side. X and x gets cancelled, so you are left with 41 upon 9. What is sin theta? Opposite side upon hypotenuse. X and x gets reduced, so you are left with 9 upon 41. So children, with both the methods, we were able to find out the value of the unknowns. So this is the way, children, given to you any trigonometrical function value, you have two methods. Either you use the first method by using trigonometrical identity and any other formulae to find out the value of unknowns, or whatever is given to you, that basic function, the ratio, convert it into the measurements of the lengths of the given sides as per the required material given to you over here, the values given to you over here, and then by using Pythagoras theorem find out the third side and then go in for finding the unknown values.